All right, going to do some more trig work here, get those conversations started. And this particular video is going to be about how we can look at some sinusoidal curves with just a little bit of data and how we can write that equation in 10 seconds or less. That's our goal. It's going to take some practice and it's going to take some initial conversations. And this is about the second or third time I've started talking about this, which means you may not have heard anything yet. All right, we're gonna have to keep talking about it. So I'm gonna use a sine function. I think it's a little easier to teach this with the sine function. Most textbooks would use cosine, but hopefully we'll see why I'm doing that as we move along. This parentheses in the earlier video that I posted, I hope you know that's representing angles. So the argument of this function is all about angles, which we're going to be working with in radian measurements because these numbers match up nicely and we'll show you why right now. All right, so I've got my high-tech manipulations here. I brought in my charger cord. I've already lost some of my high-tech equipment. So let's put this down. All right, and if I use the cord to represent the circumference, all right, then I'm gonna, oh, this high tech is really something. I'm bringing the cord all the way around 360, and then I'm gonna unwrap it. And as I unwrap it, it becomes my x-axis. Okay, that's one revolution worth of angles right there from my left hand to my right. But I am actually gonna draw it with a marker. So this is the circumference of the circle, and I could go around more than once. So that's the circumference. What am I going to do with the circumference? I'm going to match it up to years. So this is a max. When do I get a max with the sine function? 90 degrees or 1.57 radius lengths, or rads for radian. Okay, so 1.57 radians. And so what's that distance? That distance might, let's just call it here, 1.57. Okay. And I want that to match up with the year 1903. But I'm not going to call it 1.57. What am I going to call it? Pi over 2. So I'm going to get pi over 2 to match up with 1903. And this is an x value. And I'm changing it to that y value. So I'm going to make a little table here where 1903 gets me pi over 2. Yep. And then, of course, over here, I've got another 2000. And that 2000 is going to have to act like a what? Because it's my input. It's going to have to go here. I don't like that. I guess I got to figure out what the angle is. I know 1903 is matching up with pi over 2. So what happens here? I go down and up. I go down and up. Well, that looks like once around the circle. The once around the circle we've been hearing for last week is 2 pi radius length, 6.28. Whatever this radius length is, I need 6.28 to go around. So I guess from max height of 1, right? This is the maximum height of 1 to a minimum of -1 happens from here to here. And that's half a circle, so that's pi radius lengths. If that's pi, that's 1 pi, 2, 3, 4, 5, 6, 7. I have gone pi over 2 plus 7. Pi. I have gone pi over 2 plus 7 pi. Which I guess is 1, 2, 3.5 revolutions. 7 pi. Yeah, 6 pi is 3 revolutions. 2 pi, 4 pi, 6 pi, 7. Yeah. And I think we've had enough practice with fractions now to know what that is. That's something divided by 2. Looks like I got 1 I guess that's 14 pi over 2. So I'm actually at 15 pi over 2. And that happens in the year 2000. Well, I don't know what you're seeing. I'm seeing a linear equation. And I think we're getting good at writing the equation of a line. And I think the linear equation converts the years into angles. So I think we can put those years into angles right there. I think we can write this linear equation right here. So that when I say 1900, it now becomes pi over 2. And what's the sign of pi over 2? A max of 1. Okay, so stop, write the equation, and let's put it right here. Let's put that linear equation right here. Well, how do I turn 1903 into pi over 2? We've been doing it since day one. X minus 1903 plus pi over 2. And this is going to be the sine function. So I'll move this y over here. All right, so let's put 1903 in. 1903 minus 1903 is 0, plus pi over 2. Sine of pi over 2 is 1. Oh, I got my paintbrush. Right, but I don't think I'm going up 1 and down 1 in this function. I think I got to figure out what I'm doing here. Looks to me like I'm going 30 to 40. I think I'm measuring from 35. And I don't think 35 to 40 is up 1 anymore. I think it's up 5. So I don't want to go up 1 and down 1. I want to go up 5 and down 5. Up 5 and down 5. And I think I want to measure from 35. Oh, I guess there's one last thing to do. Figure out how far is it from 7 pi over 2, from pi over 2 to 15 pi over 2. How far is it from 1 to 15? Looks like it's 14 pi over 2. Oh, that's 7 pi. That's what we counted. 1 pi, 2 pi, 3. And where does that go? Where does the change in y go? Well, I hope you say, where are we? Oh, we're here, right? Doing the linear function. I hope you say the change in y is 7 pi. Of course, it's 7 pi from pi over 2. And 7 pi takes us 1 pi, 2, 3, 4, 5, 6, 7 to a minimum. Huh. Yeah, that's going to take us to 15 pi over 2, which is -1. And what's -1 times 5? -5 plus 35. Where? Oh, minimum 30. Now, what's this linear function missing? I think it's missing the change in x. Oh, I can get that right here. 1903 to 2000. Looks like 97. So you can put that in a computer. You can write this equation, right? You can write this equation. You're going to get that graph, provided you know how to change domain and range, the window in a computer. And we talked about domain and range, but I haven't held you accountable for it. I'm gonna. So let's try a couple. Let's try another one. And let's actually just kind of write what we see. How about if we go just that? That's enough for our purposes. Let's start here. Let's start here in the year 1950. Let's say we get 100 of something. And over here, let's go to the year 2024. And let's say that we now have 130 something. See if you can write the equation. And then I'll do some matching up here. You're pausing the video. I'm just going to continue, but you can try it. Well, yeah, I don't think I'm at a max anymore. I think I'm at a min. I think a min is here. Oh, now let's see if we break this up into 4 parts, then that's pi over 2, 2 pi over 2. Oh, 3 pi over 2. And pi over 2, of course, is 90 degrees. So I think I want to start at 3 pi over 2. So that's going to be my minimum. Let's call this 3 pi over 2, just so I don't have to erase anything again. All right, and then I got to look at this and go, oh, min to max. min to max. That's half a rotation of a circle, and that's 3.14 radius lengths. So that's 1 pi, 2 pi, 3 pi. So over here, 3 pi plus 3 pi over 2 is 6 pi over 2 plus 3 pi over 2. That's 9 pi over 2, really. That's where I am. And I want this to match up with 1950. I know how to do that. I can make that happen. I can make 1950 turn into 3 pi over 2. Boy. And I know from 3 pi over 2 to 9 pi over 2 is 6 pi over 2. And that's my change in y, 3 pi. Of course, there's a change in the years from 1950 to 2000. I think that's 50. I'm going to change this number to 51. I don't like the same numbers showing up anywhere. All right, so I'm going from 1951 to 2000. I think that's 49 years. And I'm still working with heights, so it's the sine function. Okay, and I got to put that in brackets or something, and that's the argument. Years to angles. Remember, we said the argument of a sine function is an angle, and that's going to give me a ratio between 1 and -1. And what do we want? We want to go from the middle, and the middle is 0. And what's the middle up here, though? The middle up here isn't 0. I hope you said 115. Yeah, up 15, up another 15. So I think we want to measure our y values from changing y values from 115. And what are they going to do? They're going to go from min, max, min, max, min, max. Shout out to the Three Stooges. And what is my amplitude? How much am I going up and down each time? You might want to say down 15, and I wouldn't blame you, but you don't have to. You don't have to. You can just put the 15 here when you do it this way. And that's the first time I've actually used 3 pi over 2. Not sure if I'm going to want to continue that or not. I'm playing around. So let's put 1951 in. 1951 minus 1951 times something. Oh, that disappears. And I get 3 pi over 2. Well, that's right here. What is the height of 3 pi over 2? -1. All right, so this becomes -1. And what's -1 times 15 minus 15 plus 115? Oh, you know it, nailed 100. Why did I erase this? Let's get it back. 3 pi over 49 x minus, what was it, 1951. Well, let's put our next number in. Let's put 2024 in. What's 2024? That's not. Geez, I thought I was the year 2000, so I butchered that. Didn't matter for the first one, but what is the difference? 1951, 49 and 24, 49, 59, 69, 73. All right, so that should have been an elapsed time of 73. I'm not going to make the video again. Make mistakes all the time. I corrected it. We're good. So 2024 minus 1951 is 73. What happens to the 73s? They cancel, and I'm going to move 3 pi from 3 pi over 2. Well, here's 3 pi over 2. Here's 1 pi. Back to 2 pi, 3 pi. I'm right there. I wonder what the sine function is there. Oh, I think it's a max. I think it's a 1, positive 1. And what's 1 times 15? 15 plus 115. There's my 130. Of course, I could have done it as a cosine function too, but you know, you're just learning this. So I think I'm just going to stay away from that one in this video. Cosine curve is actually, I don't know. I'm just going to stay away from this one. Let's do one more, and then we'll do some in class. All right, so here you go. We'll go to here. We'll start from here. Let's year 1066. Yeah, William the Conqueror. And let's go with 80. And down here, let's go with the year 1100. Yeah, that doesn't seem like it's too hard to work with. And let's go to 50. No, we just did something like that. Let's go to 30. There we go. And I think you probably got the hang of it now. Push the video pause, right? I think you're probably figuring out the middle. 30 plus 80, 110 divided by 2, 55. And you check that, 55 to 30 is 25. If I add 25, I'm at 80. Yeah, so that's the right middle. So why don't we just start writing this from right to left? I'm gonna measure from 55. How am I gonna get to 80? Going up 25, we're gonna do the sine function. We're gonna write a linear equation, which matches what up with what? 1066 matches up with a max. A max is pi over 2. And let's make sure I don't make a mistake this time. 34 years later, at the year 1100. Very good year. I had a lot of friends. I'm at a rotation here of 1 pi, 2 pi, 3 pi, 4 pi, 5 pi, 2.5 revolutions every 34 years, starting in the year 1066. And I want 1066 to act like pi over 2. It does now. With 1066 in, 0, pi over 2, which is 1, sine of pi over 2 is 1, times 25 is 25, plus 55 is 80. And then I want to go 5 pi from pi over 2, and if I do that, from pi over 2, 1 pi, 2 pi, 3 pi, 4 pi, 5 pi, I get -1. And take 25 away from 55, and you're at 30. Okay? Again, if you're gonna learn this, the conversation has to start somewhere. Now that it's started, we've got 2.5 weeks before midterm. And then we've got until middle of May to do these every day. I have faith you will be able to do this. Okay? But you got to look at it, you got to think about it, and you got to try. All right? So whatever time you just spent on this, that's enough. Look at it again, do it again in class tomorrow, that's enough. Do it again, and I'm a firm believer 4 days from now, if you put 5 minutes in each day on this, 4 days from now, hey, some of you already have it, right? It's the 3rd day that we've done it, a little bit for some of you, and some of you, I think, can already write this. Okay, so that's enough practice for that, and we'll continue to build on it as we move forward. So you don't need to watch me erase the board. You need me to click off the video. See you in class tomorrow.